In this class, we will discuss about some of the concepts of RCC silo. So, in my earlier video lectures, I have covered bunkers, design of RCC bunkers, both rectangular and circular. So now, we will go to another structure called silo. So, the difference between bunker and silo is both of them they are used to store a large quantity of materials. So normally bunkers are used to store petrol or diesel, kerosene, something liquids like that. Whereas silos are used to store grains like wheat, ragi, etc. and coal. So this is a typical silo figure. So here you can see that there is a cylindrical portion. Above that you have a heap here. This heap represents the material field. So whatever material is there, maybe wheat or coal. Then of course it is a cylindrical portion, that means it is circular in plan. So side walls, vertical side walls will be there. And these walls are supported by columns. These columns will run along the periphery, along the circumference like this. So columns will be like this in plan. So we can have the columns like this, and depending on the quantity that has to be stored in the silo, the spacing between the columns will be decided. And also normally what happens, there is a hopper bottom portion here through which the material flows downwards, and a vehicle normally will be there here to take these stored grains. That means the spacing between the columns and this clearance should be such that a vehicle can move in this portion and it can get the grains from the silo, stored grain from the silo. So this is a typical diagram. So here the design means we have to design the vertical side wall and we have to design the hopper bottom. So those two things are important. And you can see here there will be two types of pressures acting on the elements of the silo. One is pH, another is PV. pH is the horizontal pressure due to the stored grain, that is lateral pressure, and PV is due to the weight of the grains. So for those two things we have to design the both vertical side wall as well as the hopper bottom. So I have shown here pH acts like this, PV acts like this. Here on this hopper bottom also pH will be acting like this and PV will be acting like this. So we have to design both the components separately. So for that we require one thing called phi. So this phi, it is nothing but the angle of internal friction between the material stored and concrete, whose value will be known, maybe 25 degrees, 26 degrees, 28 degrees, like that, depending on the type of material. And the main difference between bunker and silo is suppose if you take the bottom of this cylindrical portion, if you take the plane of rupture, so usually this plane of rupture will be at an angle of 90 plus pi by 2 degrees, and if this plane of rupture cuts this top plane, then it is called as a shallow bin or bunker. Suppose if the same plane of rupture, if it cuts the opposite side of the wall, then it is called as a deep bin or silo. That means depth is more here compared to this. This is a shallow bin, this is a deep bin. So bin is a common word used for both bunkers and silos. Now, there are two theories which is used to analyze or find the pressures on the components of the silo. One is the Johnson's theory, another one is the Airy's theory. So first I will take up this Johnson's theory. So if you do the derivation, so using the assumptions and the theoretical background, so you will get the expression for the horizontal pressure like this. gamma d by 4 mu naught mu dash into 1 minus e to the power of minus 4 mu dash k by d into h. So that h is here, it is the height you see here. Suppose if you want pH value here, so this is the height we have to take. If you want pH value here, this is the height. So h is nothing but the height of grain above the section under consideration. So this h value will vary. Of course, the maximum value of h will be at the bottom of that cylindrical portion. So h will be maximum here. So your pH is maximum here. Just like your hydrostatic pressure, you have the maximum pressure here. And mu dash is nothing but the coefficient of friction between the material stored and the concrete. So that is the value of mu dash, because there will be some friction when the grain flows down due to gravity. There will be, so this is the direction of flow, there will be friction in the opposite direction. Friction will be there in the opposite direction. So the coefficient of friction is mu dash. Then d is the diameter of the silo, that is the internal diameter of the silo. So this is your d. So diameter of the silo is this. Then PV is the vertical pressure. So for calculating horizontal pressure, this is the equation we are going to use. And for calculating vertical pressure, after getting horizontal pressure, if it is divided by the pressure ratio, which is divided by K is nothing but pH by PV. So you are going to get the value of PV. And gamma, of course, is the unit weight of the material stored in kilonewton per meter cube. For wheat or for coal, for different materials, you have got the unit weight. That value we have to take. So using these two formula, you can calculate the horizontal pressure and the vertical pressure acting on the wall as well as on the upper bottom. Now the design consists of the design of both side vertical wall as well as the upper bottom. So this side vertical wall will be subjected to hoop tension, which is given by T is equal to pH into B by 2. This I am going to explain when I am going to take up the design problem in the next class. AST, steel reinforcement required, is given by 1.5 times T, because by limit state method, so 1.5 times T divided by 0.87 Fy. So normally minimum reinforcement will be there. It all depends on the type of the material and the height. So then the second part of the design is hopper bottom design. So there that hopper bottom is subjected to two things. One is direct tension, another is hoop tension. So for both these two things we have to design the reinforcement. And normally minimum thickness of side wall or the hoop hopper bottom is taken as 150 mm. So 150 mm is the minimum thickness that is required. And when you are calculating the load on the hopper bottom, the total load on the hopper bottom is given by weight of grain in the cylindrical portion. So this portion, whatever weight of grain is there in this portion, that plus weight of grain in this hopper bottom portion plus self weight of the hopper bottom. So you have to take all these three, we have to add them, that will give the total load on the hopper bottom. So after getting the load, then we can do the design. So that means finally all the silos normally they will be of cylindrical shape, that is circular in plan, whereas bunkers may be rectangular or circular. So the depth is more in the case of silos compared to bunkers, and usually the silos are designed based on the pressure criteria, considering the friction aspect also. So these two are the formula you have to use by Johnson's theory. After getting the pressures, then we are going to calculate the axial tension, hoop tension as well as direct tension, and then we are going to calculate the required reinforcement.